All right, I really was pissed off about what happened to me in class today. But anyway, because I was like, this is not making any sense. It's not making any sense. And then it finally, and then when I left, and I went right to the lounge bed, look, they put that guy at the origin. So, okay, in other words, and what batteries? You know, you all know what a battery looks like, right? Right? It's got positive end, it's got its negative end. Well, here it's got a positive. This one's right on the ends there. Okay, and what they do is charge around. All right, and it takes chemical energy and converts it into electric potential energy, and then current is the work done that takes that electric potential energy charges around. So we have current, and things operate electrically. Okay. That's the big idea. That's it, and that's chapters 19 and 20 right there, and currents work, and then putting podge of mixing all of that stuff together. All right, so that's what we're doing. So the main thing I want you to know, and I'm going to get my mug off the screen. I just wanted to apologize for that one problem again. You know, you didn't look at this morning. You had plenty of time before I got in the car and drove in, and done these problems a million times. Never done that one before, and then I forgot to read that it was it's at the origin. Duh. Now I got it. All right, so anyway, here we go. A potential energy and the electric potential, two different things. Okay? They are absolutely two different things. All right? So, potential energy. You know about gravitational potential energy, right? Let's talk about that. Real quick. So this is lecture 3, I think. This is video lecture 3. Video lecture 3 for Physics 220. All right. So you know about gravitation. So if we have an object, let's say it's on a cliff. This cliff is 40 meters high, which is pretty high. And we drop this little basketball here. We neglect air resistance. Well, right here, it's got a gravitational potential energy that equals the mass times the force that's pulling on it times the height up above the earth that it is. And that's a positive number. I know we wrestled with that quite a bit because we're like, well, wait a minute, gravity's negative. No, this is a scalar. This is a scalar. This is energy, and it's mgh. Right? mgh. So that's gravitational potential energy. And when we drop this ball, that gravitational potential energy turns into kinetic energy. As the ball goes flying along, and it's got velocities that all these velocity vectors get bigger and bigger the closer and closer it gets to the Earth, and then so it's got its kinetic energy, which is 1/2 mv squared. And we'll look at that for particles too, getting pushed through a voltage. All right, and we look at the mass spectrometer in here and a few other things. All right, so that's the big idea behind this. So I'm going to stop here just with that, and then we'll look at their first couple of slides, and then we'll look at one homework problem, and then we'll be done. And then I'll see you on Wednesday.